Hello and welcome back to Every Problem. This is Stewart Calculus 8th edition, section 1.1, problem 35. In this problem we're asked to find the domain of the function h of x. It says h of x equals 1 divided by the fourth root of x squared minus 5x. Okay, let's write this function out really quick because then we can annotate it a little bit. So 1 over the fourth root of x squared minus 5x. Okay, well, because we have an even root here, right, the fourth root, an even root, that means that we cannot have a negative number underneath that square root or that fourth root, right? So no negative numbers are allowed, and if we think, okay, well, what would make x squared minus 5x negative? Well, anything that would make that negative, let's see. If we plugged in 0, we would just get 0. If we plugged in 1, we would get 1 minus 4, and that would give us negative 3. Okay, so it looks like anything above 0. Now, if we plugged in 5, we would also just get 0. But if we plugged in 6, well, that would give us 36 minus 30, which would equal 6. Okay. So we do know that anything in between 0 and 5 is no good. Anything between an x value 0 or 5, that's going to give us a negative number under that radical. And we know that that cannot be part of our domain. In addition, because if you look here, I'll circle it in yellow, because this is in the denominator, we also cannot have 0 in the denominator because that will give us some undefined answer. And so luckily we did figure that out. We did find that 0 as an x value will give us 0, and we also found that 5 will give us 0. So what we know is that x can be less than 0 because, right, if x is a negative number, then this x squared, well, anytime you square a negative number, you'll get a positive number. And then minus 5x, well, if x happens to be a negative number, then that minus 5x will turn into a minus number, which will be plus. So that means any negative number will in turn give us a positive number under that radical. So any negative number is good all the way up to 0, but not including, because otherwise 0 will be in the denominator. In addition, let's see, so we can't have 0, we can have any negative number, we can't have anything from 0 to 5. So let's just get started with this. Let's write domain and the domain is going to be equal to open bracket, right, because we can't include negative infinity. We can only have as far up to negative infinity as we could go. There's no point that's infinity because, right, infinity keeps going. So from negative infinity all the way to 0, but not including, that's why I have that open bracket. And then union, meaning including, in this case, including another interval. And we're going to start, let's see, we'll have open bracket 5, because, right, if we input 5, it's going to give us a 0, and that 0 is in the denominator. So we can't have 5 exactly. We could have something close to 5, and that's what the open bracket is for. So it's everything up to 5 but not including. So from 5 all the way to positive infinity. And that is our domain for problem 35.